Hey, what's going on everybody? Gareth at FCP Euro. Welcome back to another DIY video. Today, we're going to be working on this E92 328i on the lift behind me. So what we're going to be specifically doing is replacing the front control arms. That includes the thrust arms, the wishbone. This vehicle was involved in a curb strike, so we have some front suspension damage. But while we're in there, we decided it was a great opportunity to install this M3 control arm upgrade that we offer. This takes the control arms from the E90, E92, E93 M3, and E82 1M, and all we're doing is installing it onto a standard E90 328. As long as it's a rear-wheel drive E90, E91, E92, E93 3 Series, or an E82, E88 1 Series, you have the option to upgrade to these M3 control arms. And we're going to talk about some of the specifics, some of the advantages, some things to be aware of when you're installing this kit, but it is fairly straightforward. Do need a couple special tools, we'll talk about that. But before we go into the process of how to replace these control arms and install them, and some of the things you need to be aware of, let's talk about some of the tools we're going to need first. So some of the tools you need in order to replace the control arms on your E90, E91, E92, or E93 rear-wheel drive 3 Series, really not that much in terms of sizes. 18mm and 21mm are going to be the most common. You're going to want a T40 socket for the counter hold for the ball joints on the control arm. I have a little 8mm socket here for moving the splash shield if you want to choose to do that. 18mm or 21mm wrenches, a 9mm wrench, and a 10mm socket if you need to install a new headlight level sensor. You're going to need those two wrench sizes. Varying ratchets, a torque wrench that can do at least 175 newton-meters of torque, and if it can do torque angle, that's even better because you do need to torque angle the control arm bolts. Over here, pry bar, that's going to help remove the control arms from the subframe. Deblo hammer, useful for getting the control arm back into the subframe because it is a pretty tight fit. Flathead screwdriver, it's pretty much used as a pry tool. It's kind of like the pry bar except a little bit smaller. And a little bit of a little brass punch here, which you'll see in the video I'm going to use to basically tap the wishbone into position because it is very tight on the subframe and this is not going to damage that inboard ball joint. Also, since you are going to be working under the car, light can sometimes be a problem. So if you have access to a little work light like this, it's going to make your life a little bit easier. So now that we've gone over the tools, let's go ahead and get into actually replacing these control arms on this car. First thing we're going to do here is partially remove our fender liner and splash shield. There is an 18mm M12 bolt in here for the thrust arm we need to gain access to in order to remove the thrust arm. So basically it's all held in with 8mm fasteners. And we're just going to remove a series of these so that we can peel everything back enough to gain access to what we need. Next we're going to remove our 21mm nut here for our wishbone at the knuckle. This can be torqued pretty tightly, so leverage can be your friend. I've turned the wheel, since we're working on the right side, to the left. That way as I try to remove this nut or spin it loose, I don't have to worry about the steering moving on me. And it did come loose. And it does appear that it's currently spinning without moving the stud. And now the stud is moving. So at this point, we're gonna go ahead and use our T40 counter hold and a 21mm wrench. And we're just gonna spin the nut off. I wanna do this so that at some point I can actually spin the stud of the ball joint, but I don't wanna do that until the seat is far enough down that it's not touching the knuckle. Reason for that is there's some notches on the ball joint seat and I don't want them spinning against the casting of the knuckle. It looks like it has come down far enough, so now I can actually spin the stud of the ball joint. Fortunately, this ball joint came right out of the knuckle. It has a very small taper, so it sometimes actually works with you as opposed to against. We'll just leave it kind of threaded loosely for now. Next up is our tension strut ball joint nut, which is right here. I don't want to completely remove this yet because if we do remove this, then it's going to have a tendency to wobble back and forth. So I want to try to leave that somewhat stable. Again, I'm going to use the stud of the ball joint with the T40 counter hold. And I'm just going to spin the ball joint stud so that it unthreads off the nut. You're probably not going to be able to see this from where I'll be working, but there is a M12 18mm bolt that goes through. The nut is encapsulated on the subframe right there, so it's a little just tab that goes in there. We're replacing it, but what I'm going to do now is remove this bolt Trying to avoid removing as many screws and bolts as I can. And now from this point, what I can do is pull the tension strut back and out like so. So I'm gonna go ahead and remove this nut. You wanna replace these. Kind of clips into place. On the subframe. It's got this little tang. That little tang locks into the grooves here on the subframe. So just kind of push that out and I was able to slide the whole nut off. But you can see how this nut's floating in here. It's pretty much so you don't have to hold the wrench up here by the sway bar because there's very little room. So this is how BMW does it on the rear-wheel drive E90s. You don't have to worry about holding a nut for the thrust arm. Next up, we're going to release the 18mm bolt that holds the wishbone to the subframe. So now that we have the control arms down on the right side, I thought it'd be a really good time to talk about the differences between the M3 specific control arms and the standard E90, E91, E92, E93 3 Series rear-wheel drive control arms. Starting with the tension strut. The tension strut itself is exactly the same dimensionally. Everything is the same with the exception of the inboard bushing. So your factory thrust arm bushing, this is a hydraulic bearing, so it's an oil-filled bearing, really, really good for vibration damping and absorption and NVH and all those things that makes the car kind of comfortable, but kind of terrible from a performance perspective because it causes this thrust arm to move around quite a bit at the mounting point out of the subframe. The M3 control arm specifically, it has this rubber bushing, it's solid rubber, and you can see it kind of has these tiers to it. In a way, this inboard bushing has a spring rate to it, so it doesn't move around or pivot nearly as much as this hydraulic bushing would on the stock control arm. So the big advantage there is, especially if you're looking for somebody with a little bit better feel in the car, just replacing this to the M3 control arm bushing is going to make a difference. To take it the rest of the way, we have the rearward wishbone, which you see here, and visually it looks entirely different. Two important things. Number one, this just has a standard rubber bushing inboard at the subframe, while the M3 control arm specifically has this bearing ball joint. It's a sealed unit. This allows this control arm to pivot all over while maintaining its standard pivot point. It can't deflect or move around. The other thing to note is this M3 control arm is also slightly longer. It's going to be hard to tell on camera there, but the key on that one is this will give you anywhere from 3/4 to 1 degree of extra camber on the front. And from a performance perspective, that could make a serious difference with how the car handles and how it feels. Now, camber is generally associated with tire wear, but that's not necessarily the case. If you have a really bad toe angle and camber, yeah, you will probably wear the inside of your tires quite rapidly. One question that we get a lot is what setting should I set the suspension to? And honestly, if you have factory top mounts or you don't have camber plates or anything like that, there really isn't anything that you can do with camber outside of notching your strut towers, and generally that's not too much of a recommended thing to do. Camber is pretty static. The only thing that you can change is toe, and whichever car that you have, that toe angle should be set to the toe angle that is set at, you know, whichever shop you're using for alignments. Just go off the toe angle that's recommended for your vehicle. You'll be perfectly fine. If the camber is obviously going to be higher, that's not going to be an issue as long as the toe is set to the correct angle. So whatever spec that needs to be, just make sure it's set to that. You're going to be perfectly fine. And like I said, that extra camber is going to make the front end feel a little bit different, but it does help with turn-in and everything else. So from a performance perspective, this is a really nice kit. It is the top control arm kit that we sell. And honestly, in a weird way, these TRW branded control arms from TRW, they make the control arm for BMW for the M3 and the 1M. These are actually cheaper than the standard replacement control arms, which is why most people go with this option. So the wishbone is always going to be probably the hardest one to get into the subframe. Deblo hammer and start tapping it in place. It's just a little bit of a tight fit, but that's normal. Even the standard arm is a tight fit, so dead blow hammer is kind of the way to go to get this going. So as you can see, that was a little bit of a wrestling match to get that in. The M3 control arm, I've seen some sizing variations on these, but I think it's just fractionally wider than the non-M3 control arm. And so the subframe needs to sort of open a little bit. And plus, when you tighten these bolts down, you're also pinching the subframe kind of closed a little bit. However, the good news is, being a ball joint, it doesn't matter what ride height we torque this at, because this whole thing can, like I said, it can pivot and move along nicely, so we can torque this right now if we wanted to. I'm gonna wait to do that, but I wanna show you the really nice advantage that this provides over the standard arm, which is just rubber bushing, which is going to be in a bound position at whatever it's torqued to. So next up, we're gonna go ahead and install this new encapsulated nut. Like I said, it kind of just sits here, like there's a notch on the subframe. So it's just a matter of getting this little locking tab to sit here on the subframe and get those two tangs to sit in the groove. Just gonna open this tang the slightest amount with this flathead screwdriver. When they're brand new, they have a lot of spring-loaded tension on them, so I just need that open a little bit so I can slide it into place. Next up, I'm gonna go ahead and install the new thrust arm. You need to make sure that the ball joint is up over the top of the tie rod first, otherwise you're gonna find yourself in a little bit of a jam there. So just make sure that the ball joint is kind of seated first. And then, from there, you have to wrestle with it a little bit, get the bolt started, but it should catch by hand. This bushing, we will have to torque at ride height because it's a traditional rubber bushing. This one we can torque where it is. But from this point, what we'll do is I'll go ahead and get the ball joints tightened down first, and then we'll do our bushings inboard. So again, T40 for the counter hold, 21 millimeter for the nut. Gonna go ahead and start tightening the nut down. The new nut included with the TRW arms is a nylock, which I kind of prefer over the deformation nuts that BMW uses. But again, like I said, we're just gonna go ahead and bottom out these nuts first, and then we'll torque them to spec. Spec is 175 Newton meters. For both the wishbone and thrust arm, it's the same size thread. We're gonna go ahead and torque to 175 Newton meters. Of course, the suspension is gonna move on us, but once we turn it in the appropriate direction, we can go ahead and tighten the nut. And then we're gonna do the same thing for the wishbone. Bingo. So we're gonna go ahead and thread this bolt in. So there's two different torque specs for these inboard bolts. If it's a 10.9, class 10.9 bolt, which you can see on the head of the bolt, it's gonna be 100 Newton meters plus 90. If it's an 8.8, it's 68 Newton meters plus 90. I have no idea why there's two different classes of hardness for bolts for this, but there is. So just be aware of that difference. I imagine if you try to torque the 8.8 to 100 Newton meters and then go 90, it's probably gonna break. Or overstretch. But either way, just be aware that there are in fact two different hardness ratings for the hardware on these cars. So like I previously said, we don't need to worry about torquing this inboard ball joint at ride height because it's a ball joint and it could pivot no matter what. So you're not introducing any kind of bind here. And again, these are 8.8 bolts, so 68 Newton meters, and then we'll do 90 degrees of rotation. All right, so now we'll go ahead and do the 90 degrees of rotation. There we go. And now for the thrust arm, which uses your rubber bushing, we do need to torque that at ride height. So we're gonna go ahead and compress the suspension until we start seeing the vehicle lift somewhat off the pad here on our lift, which it's doing. Gonna go ahead and make sure that this bolt bottomed out first. And doing this procedure, make sure that the bushing is torqued at a neutral setting. If you were to do that with the suspension unloaded, this bushing is always gonna be in a bind and it's gonna prematurely wear on you. So this is an important procedure to do. .68 millimeters, and then we need to do another 90. So we obviously did the main part of the DIY on the right side of the car, and everything on the left side is going to be exactly the same, but the only difference is you do have a headlight level sensor on most of these cars. If you have auto leveling headlights, you're going to have a headlight level sensor, which is right here, and it's going to have a little arm that connects that sensor to the control arm itself. When you switch to the M3 control arms, you do have to change that level sensor rod because on your standard control arm, it just clips on. On the M3 control arm, it physically bolts on. So it's a completely different level sensor arm or rod, which you do include in our M3 control arm upgrade kit because it is part of the conversion. But it's really simple to remove. It's just a 10 millimeter nut with a 9 millimeter counter hold up here at the level sensor. But then when you install the new one, you want to make sure that you orient it correctly, which I have right here. They're essentially the exact same part. The only difference being that the non-M3 version has this little metal clip that secures the control arm. So all you need to do is you just kind of put them side by side. You can see that they're crimped on exactly the same way. You just want to maintain that orientation. So this side is going to go to the level sensor. This side's going to go to the control arm. What I'm going to do here is just get the nuts started by hand. The kit that we sell includes these nuts because unfortunately you're only going to have one on the car original. So my recommendation here is to tighten down this little joint at the level sensor first, so you have actual access to the self-locking nut, and then you can do it at the control arm. What you want to do when you're doing this, be careful, don't put too much side pressure on that little plastic arm on the headlight level sensor because you could break it, and that would be unfortunate because then you're going to have to replace it. There we go. And now that we've done that, we can go ahead and install it on the control arm itself. All right, so we're going to go ahead and reinstall our splash shield bolts or screws. Are all 8 millimeter. Of course, you're very likely to lose these screws over a period of time, so always make sure you have spares. Oh, would you look at that? That's a thing of beauty. So you see replacing control arms on the front of your rear-wheel drive E90, E91, E92, E93 3 Series, and also, like I said earlier, this would apply to the E82, E88 1 Series, is fairly simple. In this particular car's case, there were no issues with the ball joint taper being stuck on the knuckle. Fortunately, BMW started to move more towards a square taper, so those ball joint studs tend not to get as stuck into the knuckle. So they came right out. All real basic hand tools, 18 millimeter, 21, and T40 is really all you need. Obviously, since we did install the M3 control arm upgrade kit, and really any suspension work you do, you would want to go ahead and get an alignment after this. In this vehicle's case, there's going to be a little bit more camber than what would normally be on a typical alignment setup, but that's perfectly fine as long as the toe angle is set to what the manufacturer recommends for the specific car. You're going to be totally fine. So just make sure the toe angle is set, you'll be good. I know it's a question that we get a lot, so hopefully that answers the question on that. But really enjoyed installing these arms. It's going to be a huge upgrade in this car. But if you have any questions or comments, leave in the comment box below. We'll get back to you. Hit that like button if you like this video and hit subscribe. We have a lot more videos on the way. And as always, we'll see you for the next one. Thanks for watching.